Hello, my name is John F. Timyatis, and I'm a certified thermographer as well as an FAA remote drone pilot. You know, all over the world, there are these huge multi-million-dollar solar installations being built. Now, the hardware has a limited lifespan, so the investors, utility companies, governments, they want to ensure on a good return of investment. To that end, they use drones carrying thermal cameras to help identify any problems. Well, that kind of preventive maintenance program should also be available for the everyday person. People who decided to put solar energy, from into their home in the way of solar panels, be they on the ground or on the roofs, should have a way of identifying or being told that a problem exists. All too often, when you get your system installed, you're told to look at an app, they teach you how to use it, and as long as you see some productivity, you're okay. But the reality is many problems can be festering underneath and not affect production until they become major. So I thought it might be interesting for the average person to see what a solar preventive maintenance inspection for the residents looks like. So here's the system composed of 23 modules, 280 watts apiece. That's 6.4K. It has three unobstructed views, so shading is not an issue. The night before there was a rainstorm, so I'm taking this around 12:30 in the afternoon, and everything is clean and dry. The conditions are ideal, 33 degrees centigrade on the temperature, cloud cover scattered, 1.4 meters per second wind, that's about 3 miles per hour, and it was shot at a distance of 20 meters. The sensor was a Flare View Pro R 640 by 512 and an emissivity of 0.88. I got myself up on the roof with a pyranometer, and as you can see, with each of the different directions, we easily meet the minimum of 650 watts per meter square. Okay, so here are three views. I took some sample measurements of different modules, and the temperatures were all basically the same. There was no evidence of any kind of cell involvement, partial or full, no thermogram that indicates any kind of string involvement as well. So nothing remarkable there. Let's go indoors, take a look at the inverter. Those are the parameters from which it was measured. And right away you can see that for this Sunny Boy SMA 70, there is a hot spot. That may or may not be significant, but you would kind of expect to see some increased temperature given the kind of work that it does. Hotspot is again on the left lateral view. There's a picture also of the switch, turn off the DC going to the inverter. What is of interest is the right lateral view. That dark spot on the bottom is actually the cooling fan. And you would expect it to be warm from use, but it wasn't in use, and it didn't go on in use for the rest of the day or any other day that was reported. So there may be an issue with the sensor and or the fan, just something to note. So the one breaker switch is at the bottom right for this system, and right away you can see that we do indeed have a hotspot. Top temperature of 50 degrees centigrade. No other breaker to compare it to, but to the ambient temperature of 32 degrees means a difference of 18 degrees centigrade. That would be a NETA of a grade 3. And note the conductors also generating heat, or at least the heat transferring through the conductors. So that's of note as well. Now, taking a lateral view of the conductor going into the insertion of the breaker switch, the temperature is much greater. At this point, it goes to 58 degrees, and again, an ambient temperature of 32. We're looking at a difference of 26 degrees centigrade. So now we're looking at a grade 2, according to the NETA guidelines. May or may not be significant, but something to make note. Okay, so that's what a testing looks like. And as you can see, the modules are in good shape. Nothing going on there. Inside, though, inside the garage where I have it, the inverter seems to be hot. And more importantly, the cooling fan has not been coming on over several days. So it's either the sensor or the fan. But in any event, it's worth taking a look at. And that's something that tech is going to be contacted with. Now, according to the National Electrical Testing Association, NETA, that solar breaker is very hot. They have 4 grades, with grade 1 being the worst. This is a grade 2. So, and the fact that the energy is going down the conductor, down the wires, tells me that maybe it's a loose connection, corroded. I don't know what's going on, but it needs to be looked at. because I don't want it to break down. I certainly don't want to fire it. But that's the sort of thing that thermography can identify. Even though the productivity is good, I'm getting good results, but still there's problems that need to be addressed. And I certainly want to address it before the warranty expires. Okay, well, if you have any questions, feel free to give me a call or write, and thanks for watching.